So one of the very random things the Regents likes to ask a question about, like once every 5 or 6 tests, is this thing called Cavalier's principle. And with volumes are kind of weird. Most of the shapes that we see are perfectly standing straight up and down. In a lot of different situations, if things aren't standing straight up and down, it makes a difference in your calculation. Volume is not one of those things. So if you have a cylinder that is standing straight up and down, and then you take that cylinder and you lean it to the side, it is going to have the same value because you're just kind of taking the volume that's there and you're making it a slanted value. There's some examples of things down here that it'll show you to make sure that you understand exactly what I'm talking about. So this is very, very easy to deal with. There's basically two things to look at here. So the two figures, the two different ways they ask the question is if you have two figures that are the same shape and they have the same base area and the same height, their volumes are the same, all right, no matter what. So if they have the same base area and the same volume, they have the same base area and the same height, their volumes have to be the same. All right, so two cones that have the same circle on the bottom and they have the same height, even if they're tipped a little bit, they have the same volume. It works for anything. All right, and the way that you usually see this described is you have a stack of quarters, 20 quarters tall. It has a volume. If you take that and you kind of start pushing some of the quarters so that it makes a stack, I'm going to draw a very bad example of this. So a stack of quarters would make a cylinder. All right, so there's my stack of quarters, and it would have all kinds of different little lines in here for all the quarters. If you took your finger and pushed at the top a little bit, it would make this stack of quarters start to lean. All right, like that. Now, it's still the same quarters. They're just not all lined up anymore. So since it's the same quarters, nothing happened to it. It's the same volume. All right, that's what Cavalier's principle basically is. All right, you can ask it different ways where you have maybe the same, one of the bases is a square and one of the bases is a rectangle, but it's the same area, they're the same height, then it makes the same thing. So there's different ways to ask it. All right, so the second part says you'll have two shapes standing up straight. So that's the second, that's the part that I just did right here. Sorry, I talked about these backwards. That's that picture right there. I did it with a cylinder instead of a pyramid like I talked about in there. But that's what's going on here. Basically, look at these questions. If you see Cavalier's principle as a question in a Regents exam, all right, or on a test or something, you just need to say two 3D shapes that have the same base area and the same height have the same volume. All right, so two of the same shape, so two three-dimensional shapes that are the same type, that have the same base area and the same height, have the same volume. That's the easiest way to do it. Get it right every single time.